right, so I'm doing this wine quality classification. To back up, I've been doing a lot of reading about AI fundamentals. I was reading about the models, the decision tree, logistic regression, linear regression, and it made sense in theory, but I'm like, what does all this mean? When do I use it? So I needed to take a break and actually apply what I was learning so that it could really click. So that led me down to look at this iris classification, which I looked at a tutorial, and I was able to follow it. Again, the tutorial made sense, but when I started to look at it myself and go through it, none of it made sense. And so that's why I have all of these files here. I'm using Cursor, and so I was asking Cursor everything that I did not understand. So, for example, I didn't understand what this line meant, so it broke it down for me. I have a better understanding of what this function does, the dependencies, even all the stuff that I had to import, what does it do? And I also just had it explain everything to me step by step and why everything needs to be done. So I have a better understanding, but so my process is I look at a tutorial, understand at a high level what I'm supposed to do, and then I try to do it myself. And I keep trying to do it myself and, getting those reps in until I understand it. So now I am gonna try this wine tasting machine learning model, and I have the steps from the iris one as a guide. Also have the code from the iris one again as a guide, just to make sure I'm going down the right path. So I think the first thing, also it seems like, so I'm used to JavaScript. I haven't written code or Python in years. My understanding is you set up an environment so that things can be contained. So I activated this environment called wine course and created repo in GitHub. I didn't do that with the last one. Very reckless. Don't try that at home, kids. So I'm trying to be responsible this time. Created a repo, and now we're just gonna get things set up. All right, let's see how that goes. So I'm going to create this setup file. Import, and I'm going to import numpy, and I'm going to import pandas. I'm going to import scikit-learn, but I don't think that's how you do it. Let me look. I'll have to import OS as well. Import matplotlib. pyplot. SNSCs. And from scikit-learn, import datasets. Okay. Yes. So far this all makes sense to me. My understanding is that with numpy, you're able to efficiently work with arrays, and so a lot of the data will be in an array, and we're able to manipulate it easier. With pandas, I'll be able to create the data frame and structure the data how I want. Matplotlib, I'm able to plot the data on a graph. And then with Seaborn or SNS, my understanding is that it makes the graphs look better, it comes with its own formats and themes. And then scikit-learn, import datasets, that's how I load the data. So that's my understanding of everything. So I think first is to, I'm going to load the data. No, I want the wine dataset. Okay, load wine. That's that. And then after loading the data, I think I want to see it. I want to see what comes with it. So I'm going to say print data I do remember I can see what keys come with it, so let's do that. Python setup. Okay, and now I want to see the feature names. And then let's look at target. We'll do target names. Okay, so I have alcohol, malic acid, so these are all the feature names for the wine quality classification. I think I'm saying that correctly. Okay, we have target names, class 0, class 1, class 2, and then all of the targets that correspond to each wine. So 0, 1, and 2, similar to the iris targets. Okay, great. Now I want to create the data frame. So let's say that from what I understand, a data frame is basically like a table. So what do I want the column names to be? I want it to be the feature names. So I didn't do this. this basically makes the graphs look pretty. I tried it in the last one and I commented it out and saw the difference with the graphs. So set theme basically gives the graphs, makes it just more aesthetically, just it makes it better and easier to look at and read. Let me grab that. But I was correct. Create the data frame. So, okay, we do that by doing pandas, data frame, and then passing the data, and then the columns are going to be the feature names. Okay. So after I create the data frame, I want to see it. I want to see at least what the columns are. Okay, so it's the feature names as I expected. Now I remember on the last one, we added a target column to be able to easily like keep track of the wines and like the association. Like the target was 0, 1, or 2, and so I think we may want to do the same thing here when it comes to like training the data and things like that. So I'm going to add a target. Column. I think that makes sense. Let's see. Yeah, let's target. Okay, great. We have target. I think actually let's try, or also, so I can see more. Okay, that makes sense to me. And listen, this already is a win for me because I did not know anything about a data frame, a data set, printing it out, like knowing how to look at it, understanding what I'm looking at. So a win is a win. I'll take it. So now I think I want to plot it to see the relationships between the things. But how do I do that? Let's see, okay. Histogram. Okay. Yes. So I'm going to create, or I'm gonna just say histogram. And so in order to do that, I'm looking at the data frame, and I have to pick like a feature name that is a good differentiator of the wine quality. So we have, alcohol, and what other names? What are things we have? Malic acid, ash, magnesium. So I'll choose alcohol. I think that's a good way to see like the different kinds of wines, but we will see. No. And I believe it would be like this. Alright, let's see. Okay, it's a histogram, but what exactly am I looking at? I wonder if I can say I have this. I'm not the best typer, so. Alright, I have this histogram. But I need labels for the X and Y axis. Okay. Let's see. Okay. Boom. Perfect. So looks like it's the alcohol level, the percentage, and then the frequency is how many times like it shows up. So it looks like and then the frequency is how many times it shows up. Okay. Great. Okay, so this is the histogram. We have alcohol and frequency. So this is the alcohol levels, and this is how many times that the frequency is how many times it shows up. So, okay, that's good to know. Like that right now. Okay. So after the histogram, to see the relationship on the graph. And so I could probably do something like SNS dot rel plot, from what I remember. Probably do SNS rel plot. Takes in the X, the column name. I will do alcohol. Right? And then says Y, another column name. Let me look. Let me see. Okay. Okay. So before doing that, I want to kind of make it easier for myself to just see the target name and map that to the target. Because right now it's like, okay, the target is 0, but amongst like what, the alcohol and all these other feature names, and I can just kind of attach it to the target name to make it easier. Let's do that before this. Dot it's pretty much said the name of the target. So I believe this would be class 0. And class 2. I need to know if I'm on the right track with that. Did I use the correct thing? Yes, I'm gonna go yes. I think this is right. Alright, so now I'm going to plot it, and in order to do that, okay. So for the iris one, they used the sepal length, so I think using the alcohol column is similar. So x equals, so I have to be explicit. Okay, x equals alcohol, and then I want the y-axis to be the target. And right, what do I want to like separate the colors by? And we're gonna say target name. I also want to do another plot. Let's try something else. Let's look at flavonoids. I want to see the relationship between alcohol and the flavonoids with each thing. So, and I want it to, yeah, that's how you see it. Okay, let's try this out. Cannot interpret alcohol. X values a string, but data was not passed. Oh, I didn't. Wait. What did I miss? Right. Okay. Data equals, yeah. Need that here as well. Okay. That should be good. Alright. Flavonoids. Okay, this is a good like plot, because I'm able to see that flavonoids is something I could use to easily like classify the wine quality. It looks like for class 0, it's between 2 and 4. Class 1, it's mostly between like 1 and 3, but there are outliers. And then class 2 mostly between, let's just say 0.5 and 1.5. Okay, and then for the alcohol level, similar, but the outlier is a little bit more, and it's a little bit, seems to be a lot more overlap. I think, what are you doing here? I think, I already X'd out the flavonoids. I think I want to use flavonoids for the quality, because it was just more, what's the word? I don't know, you're just able to tell the difference and classify these more easily, I think, from what I can see. Okay. All right, so now after the histogram, after plotting the relationships, oh man, what is the next step? All right, well, I'm gonna have to look. The next step is EDA, exploratory data analysis. Okay, let's look at pair plot. So I'm going to paste this. Target name, that should be all the same. Now let's look at this. Oh, and then I do this. So this is like all of the relationships with alcohol level. Okay, it, at least for the last one, I think it looks like what I was looking at just flipped or rotated. The first one, yeah, no, I don't understand this at all. And then I can't even scroll to see I think this just confused me. I'm sure this is supposed to help me somehow, but today I won't figure that out. Okay, erasing that from my brain for right now. I'll figure out how to read all that and what I'm supposed to do with that another time. Okay, so after the exploratory data analysis, I've looked at the data, I understand it, for the most part. So now I think it's time to train it and test it, right? I have to take a chunk of the data and separate that so that it's not going to be touched until the end, and that's what I'm able to test on. That's my understanding. That's what I think is next. Let's see. All right, train, test, split. Okay, before I move any further, I did the setup. So let's save this and push it. So I really only want to push the get ignore for now and the setup. Don't want the iris stuff there. Set up created the data frame and explored the relationships. Yeah, I'm gonna do that. And now that is all set. So going to create a new branch. Train and test. All right, okay. All right, so now I'm going to train it and test it. And so data frame train df test equals, and I'm going to use the train test split function. And so in order to train it, first I'm passing in what I'm training it with, and I'm using the data frame. What do I have to say? Like target. No, I know the target is going to be the output, and that's going to be like what I'm testing. No. It's just taking 25% out. Okay, so train test split. I'm passing in my training. Okay. Alright, you have train df test. That's going to equal I'm going to use this function, and I'm passing in the data frame and saying that I want the test size to be like, I want to test on 25% of this, so take that part out. So train test. Okay, so now I'm going to take that part out, and okay, now we're going to take that part out, and I do remember that last time we dropped some columns, but I also didn't add those columns this time because, I don't know, when I think about it, it's redundant. And I mean, we're dropping it, so I'm guessing, yeah, we didn't need it. Maybe he just did it to show that you can add columns and stuff, because we added like target and target name, but it already, those things already, or target and was something else. But yeah, those things already exist in the data frame. So like, I don't know, I have to drop it. So let's see. Okay, prepare data for modeling. So it's saying X train equals the training data, then we drop these columns and then take all the values like other than that. Okay. Okay, so we train and test, and next, I think we want to like configure it to be like ready for testing and training. And so now that I have this train and test, I want to now like assign it to, like, I want to give it value. Like, I want to store it somewhere. That's what I'm trying to say. So X train. So this training data is going to be data frame, and I want it. Oh, I do remember we like dropped some columns and then got the value. So we dropped the target and the target name. Though we dropped those columns and then got the values of all the other columns. Okay, or something like that. Df train dot drop the target and target name. Okay, gotcha. Okay, let me just see what this is. See if I can do that. Target names not found. And access. Target name. Okay. Okay, so I passed in the data frame to the train test split function, and then, well, first of all, these values, let me just see. What in the world? I'm not even gonna hold you. I don't know what these numbers are. Did I do this right? Let's see. Well, let me ask. where these values coming from? No idea. So it says these values come from the wine dataset feature. When you do drop, you're taking all the feature columns and converting them to a numpy array. Scientific notation. Okay, you chose one wine sample. Each column is a future measurement adding code to. Okay. That makes sense. And see, that's why we ask questions, and that's why you understand everything, because I could have just moved on and be like, okay, well, that's what it is, but if I'm gonna understand this, then I need to understand it. So basically it seems like it just changed the alcohol level to the scientific notation. That's to see values in regular decimal format. You can use PD dot data frame. Yeah, this is what I'm gonna do. PD dot data frame exchange columns equals feature names. Or could I have just did let's see. Is that a thing? I don't know, we're gonna see. Okay. Yeah, I had a feeling that wouldn't work. Okay, fine. I'll just do what y'all said I should do. I just need to know that it all looks good before I move on. Let's see. Okay. So yeah, y'all trying to get all fancy scientific notation. Just give me the data. I don't need the headache. Alright. Cool. Moving right along. I don't want all this. Okay. Alright, so now we have the feature names for this. I think that was written by Cursor. So I'm gonna comment this out for now. Now I also need the Y training data, right? And that's gonna be no. Let's do that. And that's going to be the target. Golly. Okay, right? Because I want the output, like, I want that training data to be, you know, what the output is going to be. And that has values. So, values. Let's see. Okay, boom. Okay. So now, we prepared the data for modeling. Next, I want to say I want to fit the model. Like, or, you know, it's time to do something with this data that we prepared. In the last one, in the tutorial, he wrote out like a decision tree, which, yeah, I don't want to do that for this one. I think I'm going to skip that and then go straight to fitting it for the logistic regression model. Also a win. I didn't know what fitting the model was before I started this journey, so now that it's in my vocabulary, I understand it. I think I count that as a win. Next, which one is the iris setup? So that's what I think is next, like actually putting the model to work. But like I said, I'm going to skip that and I'm going to go to, all right, we're going to, I guess, create the model. I know I have to import the logistic regression. I think that's from scikit-learn. Let me see something. Oh, not that. From dot a linear model. Dang, what is it? Okay, let's see. So like I said, okay, yeah. I'm gonna skip this part. Scikit-learn, oh, linear model, logistic regression, okay. Oh, what's that? Okay. That's fine. I'll know it for next time. Alright, so now I have to create like an instance of that, right? I don't know why it's so slow. Okay. Now I feel like I can just like do this, right? Model dot fit. And what does fit take? It takes an X and a Y and sample weight. So the X, which my understanding is like the input, that's going to be X train. And then Y train. And then the test size, it said, right? Or sample weight. I'm gonna leave it like that. With model, fit the model. Let's take a look. Oh, you gotta, okay. So I did that, but then I created an instance of the model, but now I have to split it again. So the initial split was just to say, okay, let me take this let me take this test size so that like you're not using it, you're not training with it, or like anything, you're not testing with it. We're waiting for that until the end. So now when I create a new like model, I have to train it and test it again and split it again. Okay, got it. So before I fit that, I need to test model. No, I'm just saying. So we get this, we get that. Using a train test split again, and passing the data frame and the test size. And then instead of X train, it'll just be X T and Y T. Right? Because when you fit it, you're training it essentially. So I want to train it with this data. Right? Now, okay, I have this, I fit it, I trained it. Now it's time for predictions, right? I think so. Like, yeah, what predictions did it make? I don't think there's anything to like see or print out from this, from the training. I could see the shape of, the training data, but I think it's fine. So let's say, what is it, model dot predict, right? Okay, let's try. I want to predict what XV is, like what's the validation, right? Yeah. Do I want to predict both? It says this only takes, looks like one. Okay, and it says it returns Y pred, so I think that's right. Let's see. Fit it. Boom, boom, boom. Oh. Okay. Oh, right here. Oh, yeah. That is right. So I want to print that out. But not only do I want, I do want to print this out, but I also want to see, like, is it correct? How does it measure up to the actual data? So for the prediction, how much of it, I'm doing JavaScript. How, like, YPred, does it equal Y, the YV, the validation for the output? Okay, let's just try this. Not enough values to unpack. Okay, I think I have to put more in here. Actually, like, yeah, because I'm doing training tests, I'm doing 4 of them, but I only have a data frame. I think I need and when I pass in these arguments, I think now it's splitting them up the way that, I'm expecting it to. Because before, yeah, like I said, it wasn't enough arguments. So let me see if that's correct. So extreme Y training, okay. And then I do need some max iterations for that. Okay. So train and test the model when I'm using the logistic regression, and I have 4 outputs. I have to have those inputs so that it can split them up correctly. And then I fit it, and now I should be able to see now I should be able to see how many my model got correct. Okay. 1, 2, 3, 4, 5. Okay, that's probably not bad. Well, okay, I can find the mean, right? NP am I able to do this? Okay, cool, 94%. That's not bad. Like, well, there's a lot more true this time around than it was last time. I can't even imagine what the percentage. Well, I could do the math, but I don't want to do the math. Anyway, 94%. That's good. So we have these predictions, and so we have these predictions, trained it, tested it. I'm going to save this now up to this point. Train and tested the logistic regression. Logistic regression model. Okay, that's that. And now I'm going to create a new branch, and well, I want to call it whatever the next step is. After training, testing it, model, now I need to I think cross-validate. Now the next step is to break it up into 5 groups and have each group be have each group testing against all the other groups. I don't know if I'm saying that correctly, but I know what I see in my head. All right. So we're gonna say cross validation, right? So okay, so we have the model. Now we need to evaluate it, and that's why we're doing the cross validation. Okay, so we did the model, now evaluate. When we built the model, now we evaluate. We use cross validation to yes, cross-validation. So I know I have to import some things, and I believe it's the same as it's from the same library as train test split. So I can say cross val predict and cross val score. Those are the ones I'll be using. And now, do I create another instance of the model? I think so. Basically doing this same thing. So yeah, I'm just trying to do my best to not memorize anything. I want to actually understand each thing, really understand what my next step is and why, because that's the only way that is gonna stick. Because I can try to remember all these things all I want, but essentially it's about the patterns and just understanding each step to take. So after the predictions, okay, now we evaluate it. Am I fitting it again? Or am I splitting it again? Damn. I created the model instance. I feel like I have to split it again. No, I'm not splitting it. I'm evaluating it now. Okay. Okay. After so now evaluate the model, I'm not sure if I have to make another instance right now or for cross-validation. But let me just write some steps that I think I have to do, and then, yeah. So accuracies. So now from cross-val score, I'm scoring my model. So I want to say something like, I might be completely wrong. Well, let me see what cross-val score takes. Estimator takes an X and a Y. The X okay. Oh, okay. I was kind of doing good, okay. So, yes, I do have to create another instance. I am going to get the accuracies from the cross-val score, passing the model, passing the X and Y, which I can just, use that same X and Y, okay. I wasn't sure if I had to create a new X train and Y train or something like that, but nope. Can just use the same thing. And I want to split it. I want to split it into 5 groups. Okay. Now I want to see the accuracies, right? So I wonder if I can just do that. Make sure I'm not printing anything else. That's not good. Okay, let's see what this gives me. Okay. Okay, well, for one, it says I need more iteration, so I could probably, let's see if I get the error still with 300. But this is what each round gave me. So for the first iteration, 92% accuracy, good. It seems like second one, 100% accuracy. 90, 92, 92, 92. Okay, that's good. It's consistent. And then cross-validation is complete. I was able to see, I was able to see the mean accuracy. And so I think after that, the next step is to I was able to see the mean accuracy, see where I got things wrong. And I think now the next step is to see I saw that. Well, I shouldn't say I saw where I got things wrong, but I saw that things were not always right. But now it's time to see where exactly I got these things wrong. So I'm gonna commit this because this part is done, this step. Yeah. Okay. I think that's the next step at least. So yeah, cross-validation, and then yeah, where are we misclassifying points? So this is where we use predict. Okay, so now I'm getting those predictions, and I'm passing in the same thing that I passed in. This part of the tutorial kind of really threw me for a loop, so I probably will struggle the most with this part, I think, but I think it'll also help me to do this by myself without trying to follow the guy, and like, yeah, it'll help me understand it more. So anyway, what are we getting wrong? Well, I don't know why I said we. Just me, but okay. What am I getting wrong? I used said the prediction, basically the output predictions. I use cross val predict. So for this model, for the training data, what did I get wrong? First, let me just print this out. Let me see what this prints out. Okay, so this basically prints out the predictions from this model. Like, okay, makes sense. But now I want to know what was accurately predicted. And so we do predicted correctly equals where y-pred, or like the output, is equal what am I trying to see if it's equal to? I want to see if it's equal to the training, output training. Would that be y train? Let me see. I want to say it's would it still be one of these? Is it YV? Oh, sorry, it's Y train. Okay. So yes, it's the training data for Y. Okay, let me rubber duck this. Alright, so we print our prediction. So we have the ones that are predicted correctly, that is going to be saved into predicted correctly, and we said that is the output prediction. Does that, the ones that equal the output training data. Yes, because we split it up. So this is the input, train that, and then the corresponding values, which should be target, let me, yes, okay, it's the target values, yes, okay, got it. That makes sense, okay, because Y-train is all of the target values, or the ones that weren't split out. So basically, how much of that array equals the predictions that were given from this cross-validation. I got it. It's all making sense now. I'm locked in. Alright. So, what was predicted correctly? And maybe I should do the mean, but first, or I'll do both of them. Okay, listen, I'm not mad at it, and I get it. Like, okay, predicted correctly. These are all the predictions it made. And that's the accuracy, like that's the percentage that I got right, 93. Okay, but now, if I recall correctly from the tutorial, okay, this is what I got right, but now I want to see what I didn't get right. And so in order to do that, I can print out the opposite, which I'm used to the bang in JavaScript, but apparently in Python it's this. So okay, now this should give me the, like, it should point out the ones that were wrong. I'm gonna just take that out. Yeah, I just want to see what was wrong. So 1, 2, 3, 4. So I got 4 wrong, which that's fine. So okay, now I'm able to see not predicted correctly, and then I should like be able to plot these graphs, like the actual versus what is predicted, and then I can see which ones I got wrong. Yes, that makes sense to me. Yes, that makes sense to me. So now how do I do that? I remember there was this fig, and I don't remember the syntax and all that. So let's see. So not predicted correctly is that. So yes. Okay, so it made a copy of the data frame training data. Yeah, let's just look at what that is. Yeah. Okay. Okay, so I missed a lot of steps here. So see, okay. Got it. Okay, but I really don't understand why we're doing this. Okay, data frame predictions equals you're copying it so that you don't like change anything from the original data frame training data. Okay, that makes sense. And DF predictions. So I'm basically making kind of a new table where I'm saying for this predictions we're going to add correct predictions, and that's going to be the predicted correctly. Okay. Okay, so I'm just gonna make a note like create predictions data frame. Create predictions data frame. Data frame predictions, correct predictions, predicted correctly. Okay. And then we want to add just all of the predictions, or what the output was from my model to this as well. I'm just gonna I kind of want to specify like this was the model prediction. I mean, I guess no, that's redundant because like obviously it's the okay, yeah, because what else is making the predictions? It's the model, so I don't need to do that anyway. DF predictions equals what I got from the cross validation. And so, and then I have this. I don't feel like writing all of that. I'm not gonna hold you, so I'm just gonna do prediction label. And so each prediction it's just pred, so it's just yeah. Label. We have predictions. Prediction label equals. And now I'm mapping it just like I did for the other data frame. But let me change these names. Alright, that looks good to me. Okay, so after cross validating and evaluating, then I see, okay, what did I get wrong? I look at my predictions, I see what was predicted correctly, I see what wasn't predicted correctly, and then I make a data frame with those predictions, and I add those to this to this table. I copy the data frame that I had initially, and now I'm adding these columns. Yes. Data frame predictions. All right. And now I want to see it. now I want to see what was the actual thing against the plots for my predictions. So now I have to do that, and this is what I did not remember, like the syntax of it. So I'm gonna write it out. I don't want to be lazy and just copy it. I'm gonna write it out so that it can get in my brain. So side by side plots. Yep. All right. So fig, and then I know that this means I will have like two tables showing. Okay, equals plot, subplots, 1, 2. Subplots. 1, 2, big size. Am I bugging? No, I'm just okay, so my understanding is that I'm saying alright, so I'm like configuring and setting up the plots. I want it to be 12 by 5, and subplots I want it to be 1 by 2. Okay. So now these are my predictions. So I'm gonna plot my predictions, and then I'm gonna plot the actual labels. Okay, yeah, I'm not gonna hold you. I'm gonna copy it because. Okay. I will have all the time in the world to remember this and, get used to it. Right now, I think it's more so important that I just even know what the next step is. So, yes, SNS scatterplot. We're gonna make this, okay. So the last one that used the pedaling in the width. I can use alcohol and flavonoid. I don't know if it's singular or plural, but we'll figure that out. We're gonna color it based on the prediction label. Yes. So, and that means this will be table 1. Model predictions. Measure predicted species or predicted, like wine quality. So now I do the same thing. Actual data. I'm gonna go with the same thing. This is gonna be 2, but I'm not gonna do the data. Shouldn't be my predictions. It should be like I think I want the DF train. No. It's like actual, I don't know. Okay. Yeah. So, yeah. Everything was pretty much, oh, I'm still using, I guess I don't understand why the data that I'm using is the predictions if I want it to be the actual one, unless I did it wrong here. Well, and then it says target name. Yeah, because it doesn't have a prediction in it. Yes, that's correct. Okay, well, this is where I ask Cursor to help assist the app. So, say Let's see. It says the actual data plot, use DF train. Boom. Yes, correct. Use DF train. You're already doing that. It continues the true label. So I guess I had it wrong on the last one, but we putting that in the win column. The fact that I was able to see it and understand that something was a little shaky. Yeah. I'm locked in. Alright, so this is what Cursor suggested, so that makes sense. I have to change that. Let's keep it. So and I knew it didn't look all the way right last time. I couldn't understand why in the tutorial, but I guess I forgot to change that. But yeah, anyway. Alright, I think that's it, and then I can, or it says something about a tight layout. So yeah, let's see. Let's check this out. Maybe I have to do okay. I mean, it doesn't look that, I don't know, clean. I was expecting the same graphs that we had before, where it looked clean, then I would have just been able to see it. But I think I did use this time scatter plot as opposed to what was used last time. But anyway, let's look at it. So this is to compare where I got it wrong. So the actual data, this is what it's supposed to look like. And then this is what my model predicted. So my model predicted some green in the blue area, which I think is kind of fine, because as we can see in the things, the plots behind this, like there is some overlap. So we got 2 green in the blues, and we got some blues that should be green, but it got that one blue that's with all the other green, correct? So that's good. But and then it predicted a blue and all the orange. Okay. I mean, it's not horrible. I mean, that I'm not mad at it. It has all those, greens, and the blues are like right under it. So, I can understand why it predicted blue instead. I think this blue over here or down here, like that is the one that doesn't make the most sense. But I mean, it's not bad, I think. Okay. Bet. So we were able to see. Let me actually. Where are we, like plotting? So we finished the cross validation. And now I'm trying to see like side by side results. I'm gonna just call it side by side. That's what we're going with right now. All right, so I think, okay, we're seeing the actual data compared to the model data. And now, is it time to like, what do you call it, model tune? Like tweak the numbers, see if, or add parameters, and like make sure that it's not make sure that there's no overfitting, which I think basically means like, well, actually no, because we haven't tested it on the data that hasn't been like touched yet. So now we have to see how the model does with the data that we put to the side, I think. Okay, maybe this is how. Okay, so actually before that, I want to plot the ones that were wrong. I want to see, I mean, I could see it from the graph, but I think it would just, I'm not sure if this is like a necessary step, but I'm just gonna copy it and say X, Y, plot 2 size. I think everything is Yes. Alright, let's now I'm like, do I need all these to be? Well, yeah, because I'm trying to plot the incorrect prediction, so that all the data should be DF predictions. Yes. I think this is all correct. All right. First, I want to look at this graph. So correct predictions. These are, so yeah. Ooh. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not good, I don't think. Yeah. Don't think that's good. Okay. I did that, but now it's like, do you model tune? I think you model tune before you do the final testing. That would make sense to me. But, okay, we did that. Yes, model tuning. Which I'm going to, once again, commit it. And versus model predictions. Push and then I'll configure it after this. But okay, yes, model tuning. Now that's where I add like parameters and things to these like functions. Okay. I will need to refer back to this though to see. Okay, random forest classifier. Would I commented that out? What did I need that for? Well, I gotta go back and see why that was added. Or I can just ask. What is the random forest classifier? And how does that help with model tuning? Which does it help? I didn't ask you to add. I didn't. I didn't ask you to add. any code. I just asked a question. I wonder if I could turn that off, because like, dang, you just did the whole thing for me. I just want to know what's up with it. An ensemble method that builds many decision trees and combines their predictions. It's nonlinear, handles, less prone to overfitting than a single tree. It has hyperparameters you can tune, estimators, and often outperforms simpler models like logistic regression, adding an example to your code. Added code that demonstrates the random forest classifier and compares it. Okay, so basically, I think it was commented out because he probably mentioned that this is another model that we can use, but he did not use that in the tutorial. So probably after this, I will look into the random forest classifier model and see how it can be used with this as well. So for right now, I'm gonna put that on hold because I'm happy with where I'm at right now. We almost done. And yeah, so I'll figure that out later. Okay, cool. I'm gonna undo that right now. Back to the regularly scheduled program. So here, with the models, you can add this param C, and I'm able to see the different accuracies based on what value of C that I give it. And of course I want the highest value, and I also remember adding things like scoring equals accuracy. This was added for the model tuning. So now I'll add this for my cross validation. And that was in score. Okay. Score, so I will do the same thing here. So for this parameter, I'm trying these different values and seeing which one gives me the highest accuracy percentage. Yeah, I want to do that as well so I can see there's what. Alright, let's see. I don't want to do that. Okay, let me, try to do 400 so I could get rid of that message, cause it's messing me up. I'm not gonna deal with that right now, so okay. Well, I got with 3, it looks like I got 95% accuracy. Yeah, it's all the way up here. Okay, and with 2.9 though, I got 96%. So that is the highest one right now. 90. So what's before 2.3? So with 2, I got 95% accuracy. 94. So that's not so. I'm just based on these numbers, 2.9. That's what I'm gonna use for C when I pass it in for this last step, which is the final testing, right? So I believe do like this. Model. I'm gonna use 2.9. I want a percentage over, or I'll say 94 and over. So, alright. 2.9, and then I use the training data that we put aside, right? I fit it with that data. Which is DF test, right? Right? Damn it. Man. Okay, well, yes, do that. So I fit it with fit is going to take an X and a Y. Okay, so I have an instance of this model. I think I fit it. It's going to have an X and a Y. The X is going to be, let's say, X chain, and then we haven't used DF test yet. I don't think. Alright, so let's see. Okay, okay, so there's an X test and a Y test. The X test is testing, and you drop those columns just like you did with the training. Okay. Drop columns and drop the target and target names. Target name. Values, and then Y test, DF test dot. No, it would just be the target. Yes. And so when I fit it, it'll be X test and Y test, right? What the heck? Train final model using full training data set. Okay. Oh, but okay, yes, this is just for the training, right? This is not. No, yeah, the test wouldn't go in for the fitting, so that makes sense. So I was right at first, I think. Did I say the training? Anyway. Why training? So okay. Full data training set. And now I fit it. Now I want to see what the predictions are for this model, correct? And is it predict? I think. And predict takes an X and only an X. So I want to predict what Y test is. No. Well, no, it's the output. So I want to predict what the output of, right? Okay. Predict class labels for samples in X. So to me, that tells me it's going to be X test in here. Boom. Okay. Yes. So I give it a name. So we'll call it Y test predictions. And I want to see the ones that were predicted correctly. Then I want to see the test set that was correctly classified. So that's all I'm writing. Does what I predicted for my model equal the actual like data, which would be the Y it would be the Y test. Yeah, because that's the actual training. That's what I put to the side. So, yeah. And then the accuracy, I'm just gonna do that. And now, I think now I want to see all of this, right? No. Well, yeah, I did that right here. And now I want to see these things. So I'm going to print. Let's just see the accuracy. Print. Okay. Let's see what that gives. That is not good. 91? Where did I go wrong? Oh, Lord. I wanna something I don't wanna do that again. But yeah, I don't know. Let me try that again. It was a glitch. It was a glitch. That wasn't for real. I was joking. Okay. This is much better. The first one, that was for play. It was nervous. It was shy. This is what we're going with. 96% basically. So let's stick with that. And I want to see which ones we got wrong. So I'm going to do probably the same thing with the fig and all of that. I think I can use the same function. No? Let's save that. Okay, I have to make a new data frame for the testing things, for the ones that we set aside. So a new data frame. Yeah. Don't be like me. Don't copy and paste, but correct predictions. I think yeah, I'm just gonna try to there you go. Prediction label. Okay. I don't want to do that. X-axis. Flavonoids. Okay. I think that's good. And now yeah, I do still want to see that. The other one, comment out other things. So I don't need that. That's it for now. Alright. Over 94. Alright. Ooh. He said, I'm gonna show you. Okay. Love that. Alright, so I did need this. Well, that's because in here, so I was supposed to comment that out. Dang. Bro, give me that again. Let's do it again. You ain't about it. You won't. What did it give me? Hold on. Oh, I didn't say yet. I have to exit this for it to. Okay. Anyway. Predictions 1, 2, 3, 4, 5, 6. I feel like that's not 97%. Yeah, I don't know. Okay. Got 6 wrong here. Why didn't it say? It must have been. It had to be. Way. Yeah, it's just. And then I called it again. Okay, well, but it always got over 90, so, except for that 88. But that was when we were doing the cross-validation. But yeah, other than that, always got over 90, so I think that's good. What else does this do? And yeah. That's all she wrote, folks. Okay. Takeaways. I have a better understanding of the steps to take. When I was doing the tutorial, like I said, it made sense in theory, but walking through it now, it definitely made more sense. And just like talking about it out loud starts to make more sense. Obviously, I gotta do more for it to really stick. But it does make more sense to me. I think the thing that I'm not fully understanding are the models. Like, I don't know, I just figured there would be, I didn't realize that, like, basically you just put in the data and then it just does it for you. I thought there would be more typing it out, but yeah. The next step, I'm probably going to add a random forest classifier to this, just so I can get some practice with it and understand how it's apparently like a better model than the logistic regression model. Definitely happy with how this went. I feel like I got some wins. Obviously not a pro yet, but I would love to see in doing this more where I'm at in like a month, and if I'm able to just kind of like do it myself without much help or referencing these steps. All right.